In this video, our goal is to find what's called the greatest and least values, and we're going to learn this through an example. Find the greatest and least values of the function polynomial given f of x equals x cubed plus 3 halves of x squared minus 6x plus 4. And we have a restricted domain, and the interval is from -3 to 3 inclusive. We need to make sure there's no discontinuities is one of the key jobs. Being a polynomial, there are no discontinuities, no asymptotes or areas where this function is undefined. Polynomials are defined for all real values of x. So we look on to stationary points next, so we need to find the derivative f dash of x. So we have 3x squared plus 6 halves, so that would be 3x minus 6 as our derivative. This has a common factor of 3, and then the contents of the brackets can be factorized. It's a quadratic. So once we factorize it, we've got to apply the fact that stationary points happen when the derivative is equal to 0. So we set it equal to 0, and through our null factor law, we've got x equals -2 and x equals +1 as are the x values of the stationary point, so we write those in. So looking at the nature of the stationary points, I've completed the table for you, and just to speed up the video, and this is familiar to us, we need to look at the nature of the stationary point. So the first stationary point at x equals -2, we get convenient points just either side, and we see that it's rising, has its peak at the stationary point, and then it's falling. So we have a maximum there, and at the other stationary point we have a minimum. So that's familiar work to us. So subbing those values into the function, we get the stationary points -2, 14, and 1, 1/2. Next we look at when we have the y-intercept is when x equals 0. So we set x equal to 0 and we calculate the value for y. So y is 4, or in other words, if you're using function notation, f of 0 equals 4 once we plug it into the original equation. It's pretty easy to see because if you look at it, it's really the 4 that's the constant, everything else is wiped out. And looking at the boundaries now, that might be something new. Now remember, the domain was restricted. You saw just before that restriction on the domain was from -3 up to +3 inclusive. So the boundaries are when x equals -3 and when x equals +3. So we've got to calculate f of -3 and then f of +3, because we're after the greatest and least values. So that could be happening at a maximum / minimum scenario, and or it could be happening at these endpoints. Okay, it depends on the nature of the curve, so we have to check all of them. Greatest and least values are when the function is at its highest and lowest quantity, and when it has its highest and lowest value, it can happen at the max, at the min, or at the endpoints, or a combination of those. So we have to test also these endpoints known as the boundaries. So just to save time, I haven't shown the full working, but if you sub -3 into the function, you get 8.5, and if you sub +3 into the function, you get 26.5. For these, draw a sketch if it's helpful or if it's asked for, and basically you see that the greatest and least values are pretty obvious. The greatest value there is 26.5, and the least value is 1/2. It doesn't actually cross through that interval. It doesn't actually cross through the x-axis. So we've got our answers basically. So the dependent variable values are, the greatest value is 26.5 and least value is 1/2.